the angle between the vectors problems. Here you need to remember the formula of the angle between vectors. And we actually just recently learned two of these formulas, one using dot product and the other one using cross product. Do you remember any? So here they are. Here is the nice illustration of the angle between two vectors A and B, angle called theta. So either we perform dot product, A times B equals magnitude of A times magnitude of B times cosine theta. And then from here, you solve for cosine theta and then you solve for theta. Or we perform a cross product. Magnitude of the cross product of A times B equals, again, magnitude of A times magnitude of B times sine theta. And you solve for sine theta and then you solve for sine. Some students memorized that you need to find cosine theta, which is A times B over A times B. But at the denominator, there will be a magnitude, which you can show with 1 or 2 bars. But I don't like using only 1 bar because it looks like absolute value. 2 bars is actually better. Or for the cross product, it is sine theta, which is also a fraction, but this time it's a magnitude of A cross B all over magnitude of A times magnitude of B. In both cases, it should be a final number. And then you solve for theta. How do you solve for theta? You need to use inverse functions here. So theta will be arc cosine or cosine minus 1 of the whole piece. Or theta will be arc sine or sine minus 1 of the whole piece on the right hand side. Well, which one you prefer to do? The cross product or the dot product? Well, obviously the dot product is faster, so unless you're told to use cross product, I would avoid doing that. That is why let's just use dot product, which is the formula number 1 with the cosine, not with the sine and cross product. Solution. Angle, and I like writing down cosine right away. And this nice looking fraction, usually I do not like writing down theta equals arc cosine. It's nice to write down cosine theta. Cosine theta will be a dot product of 1, 3, and minus 1. And a dot product is a scalar product, so the answer, we have different vectors here. 3, 4, and 1. I'm looking at a different problem. And then 2 minus 1 and 2. Scalar product means the answer should be final number. Then I need to find a magnitude of 3, 4, and 1 times a magnitude of 2 minus 1 and 2. The other way around. Vector, magnitude, magnitude. Writing it actually is harder than the calculations. So when you calculate it, it goes very fast. 3 times 2 is 6, minus 4 times 1 is 4, plus 1 times 2 is 2. All over a square root of 3 times 3, that's 9, plus 4 times 4, that's 16, plus 1 times 1 is 1, multiply. Square root 2 times 2 is 4, minus 1 times minus 1 is 1, plus 2 times 2 is 4. Just like I told you, calculating it actually is much easier than writing everything down. Oh, something is wrong at the top, because why would we have 0? I don't remember having 0 at the answer. 3 times 2 is 6, minus 4, plus 2. Yeah, everything is correct. 6 minus 4 is 2. 2 times 2 is 6 minus 4 is 2. 2 plus 2 is 4. kind of blink out for a second. And then at the bottom, we will have a square root of 10 plus 16 is 26 times a square root of 4 plus 4 is 8, and then square root of 9. That's going to be 4 over a square root of 26 times 3. So you can keep it as 4/3, 1 over a square root of 26. You could simplify 26. 26 it is 13 times 2. Not really helpful. You could derationalize the denominator if you want. Too much extra work, I think. After all, this is Calculus 3 material, and if you really want to play with algebra, just have some free time and do it. And I will keep it as it is. The most important part is over here, because I would start writing down the formula right away. 6 minus 4 plus 2 over the square root times the square root gives me 4/3, because square root of 9 is 3 over square root of 26. Thank you for watching.